Welcome to Webinar Wednesday. Today we are joined by Lucio Simoni, Engineering Manager at BC Group International. Webinar Wednesday would like to thank today's sponsor, BC Group International Incorporated. BC Group is a biomedical test equipment manufacturer and distributor for over 75 brands of products. BC Group sells directly and through dealers to medical device manufacturers, independent service companies, and hospital biomedical or clinical engineering departments. For more information, please visit bcgroupstore.com. Save the date for our next MD Expo, October 11th through 13th, 2022. The MD Expo SoCal will be nestled in the Temecula Valley, picturesque Southern California wine country at the Pachanga Casino and Resort. Registration is now open online at mdexposhow.com. At the end of today's webinar, we will have a live Q&A. You can submit your questions at any time using the questions feature on our webinar dashboard. Today's webinar is eligible for 1 CE credit from the ACI. You can obtain your CE certificate by completing the post-webinar survey. The survey will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit from the ACI, and you'll be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. As I mentioned earlier, Lucio Simoni, Engineering Manager at BC Group International. He will discuss infusion pump testing utilizing the BC Biomedical 4-channel IPA 3400. Lucio, you may begin whenever you are ready.
Hi, my name is Lucio Simoni. I'm the Engineering Manager for BC Group. I'm sorry I can't be with you today for this webinar. I'm out in the woods with my Boy Scout troop, but I thought it would be good to at least introduce myself and describe some of the training videos that you'll be watching. As I mentioned, I'm the Engineering Manager for BC Group. I've been with the company for 26 years. I've had my hands in just about every product that we've developed and manufactured over the years. And the IPA 3400 is a great example of how we like to design products. In these videos, we'll be demonstrating the use of the IPA 3400, how to do the specific testing that's available, the flow test, occlusion test, and PCA test, as well as the other features and functions that are available on the unit, such as auto sequences, saving reports, configuring, and using the unit. We'll also demonstrate how to remove a flow module for doing annual calibration. And if you have any questions at the end of these videos, there will be the lead engineer from this project available to answer any questions that you might have. Thanks again for your time and interest in BC Biomedical products.
Again, this can be somewhat intimidating as to what do I do. There's a lot of buttons. But in this case, we've broken them down into the different groups. So the only testing you can do, it's a flow test, the PCA test, or an occlusion test. Now you might say, well, what's PCA? Well, that's patient-controlled analgesic.
Right.
So they have the button, and it does the ejection.
Need some more morphine.
Right. So that's going to be a pulse of fluid, and then a pause, and then another pulse, and a pause.
Yeah, pulse, right?
So, and again, we're still measuring flow, but it's a different algorithm. It's a different set of displays that are up on the screen, and that sort of thing. So we can measure how many doses were given, what's the time in between doses, what's the dose volume, the dose flow rate. You don't need that for a flow test, so that's why it's separated. Then we have auto sequences over here. Again, we can load an auto sequence, view previously run, or create an auto sequence here. The cleaning mode, that is, the idea there is after you've run for so much time, you should clean the system out, and we run micro 90. I think it's a 1% solution of micro 90. And that just, again, we always tell everyone to use distilled water, which they never use. And so, tap water will leave residue behind. Because even if you take this off, you do drain and all that stuff, there's still some fluid in there. And if it'll just build up stuff, and the clean allows you to get rid of that. So, DUT information allows me to put information.
Can you use the syringe to force the
Oh, yeah.
residual water out?
You can.
Should we not do that when they send it in for a cal and stuff like that, so it doesn't freeze in there?
Well, when we do the cal, we use the micro 90.
I know.
So it's essentially cleaning.
If I'm sending it from Minneapolis to here in the winter, shouldn't they drain all that water out?
Oh, drain. Yes. You should do the drain before you ship. That's correct. But we can have different DUT information for each channel. Down at the bottom, it tells us which channel we're working on. So in this case, I would put in my Alaris. I can type everything I want on here. If I had a USB barcode scanner, I could scan the barcode and it would put the information in for me. Same thing on the 2400 as well that we were just doing. The barcode is just barcode scanners are just keyboards. It doesn't
2300 or
2300, 2400, 2400H. Anything that we have, anything that we have with the USB port, take it as a keyboard. If you can plug a keyboard in, you can plug a scanner in. And so that's another question. Why do we have, this one has 4 USB ports on the back. What are you going to do with those? Well, you got a flash drive, you got a keyboard, you got a mouse, you got a barcode scanner. Well, there's your 4. So, anyway, DUT info, you can do that.
That's nice that you can just scan, barcode scan.
And so they can print out their own barcodes, put it on there, and do whatever they want, or they could use the OEM barcodes, that sort of thing. They can even do 2D. If you get a 2D barcode scanner, you can pack a lot more data into that 2-dimensional barcode. So then we have our prime and drain. Again, Ken just mentioned drain. Before you send in the modules, you should really do a drain to clear all that fluid out. And actually, when you're done testing at the end of the day, it's even a good idea to drain it to get all that residual fluid out as much as possible. Priming, that's you just run fluid through to get all the bubbles out. I kind of just did that before we started here because like this alarm is really sensitive to bubbles, and if you don't get them all out before you start, then it can be obnoxious. So you just put it into prime mode, and basically now it's monitoring pressure, and when you run flow, it'll just keep running the pump continuously. And it doesn't measure, it doesn't do anything, just allows you to run fluid through it.
So does each of the channels have its own screen?
Yes. Yeah, so this one,
Gotcha.
you could be doing a flow test in here. This one could be doing auto sequences. This one could be doing occlusion test.
Okay.
And so when I go in here, they're all idle, but they're all have their own
Individual screens.
Yep, memory.
Yep.
If we want to talk about the system info, want to talk about the clean time. This is the time since the last cleaning. And it's not, I gotta forget exactly what that number is. I don't know if I think that's accumulated cycles, or maybe it's tests. I don't think it's like minutes or anything like that. But basically when that gets to a certain number, that's when you should run the clean. And I don't think there's any alarms at this point. We didn't set up, you're due for a cleaning, It's really up to you to determine how much are you using it. I gotta clean it every time it gets to 500 or 100 or whatever. But then once you clean it, it resets that number. So.
That would be nice to have a little warning though, if you set it for 300. When you hit the 300, it gives you a reminder.
Yeah.
Doesn't shut you down, but a reminder that cleaning is due.
We could just it could be in here as far as it could be in here as far as like cleaning interval, I don't think we have that as a setting. Yeah. Okay, so channel 1, we want to do a flow test. So we're doing a flow test. When we set up our infusion pump, we have to set it up for a flow rate, set it up for volume, and it has the duration that goes along with it. So we can do the same thing here. Now, these aren't necessarily all tied to each other, because here I've got test duration set to 1 hour, but I've got the flow rate of 100 and a volume of 10. So that really shouldn't be an hour. That's a tenth of an hour, which should be 6 minutes. But so we have the ability to set it to whatever we want. Maybe we want to monitor. Some of these have a KVO, keep vein open. So after the infusion is done, it'll reduce to 25 or 20, whatever milliliters per hour, and it'll just do that continuously. So maybe I want to run it for longer to make sure that it does go to a constant flow rate and it stays there. So that kind of thing can be helpful. The test tolerance, just like the ESU, what are you interested in? Do you care about the volume delivered, instantaneous flow, average flow, or maybe we don't want a tolerance? Just run the test, give me the data. I just want to meet it. So you have all those options here. So we're going to go off of average flow, and we're going to say, what type of tolerance do you want? Do you want a percent or a value? So I could say, well, I like percent. This manual monitor says 10%. We don't force you into the same. So we're going to say it needs to be 100 milliliters per hour. We're testing off of average flow, and plus or minus 10% is our limit. The back pressure, that is the pressure that is seen by the pump. So because we have control inside, we have those syringes and we measure pressure. So once the pressure gets to this value, we start moving. And we say, okay, well, there's incoming flow. Well, because of that, the monitor may have a specification that says it will pump into 200 millimeters of mercury, whatever the pressure is. So we can convert that, we can set this up for millimeters of mercury if they want to do that, or we can say we want 0.2 psi, that's great. So anytime the pressure gets above that, it's going to start flowing and measuring the flow. Everything in here is based on pressure, not bubbles. So a lot of the other ones, we've talked about bubble detection or edge detection. Sometimes they inject a bubble and they track the bubble down a line of LEDs. We're not doing that. We're measuring the pressure, and when the pressure gets above this back pressure setting, that's when we start moving and we control to that pressure. End condition. So start condition, automatic or manual. So I mentioned when the pressure gets above that back pressure, what if I want a manual start, then I'm not worried about pressure. When I hit go, start the test. Just do what you're going to do. Whereas the automatic mode, I can hit start and it's prepped. It's ready to go. And then, whenever I feel like it, I can go over to the pump and start the pump, and then they'll be synchronized. Okay? And so I'll show you the difference here between the two. End condition, when do you want to stop the test? Again, we could have set this for a much longer time, so I want to see my KVO run for the full hour. I don't care if it's done in 6 minutes. I want my full hour of data. So it gives you that flexibility. It gives you that option. Maybe I want to run the test until I get a full 100 milliliters. Whatever you want to do. You can do duration and volume or duration or volume. So those are my options. So in this case, we'll just do duration. I'm just going to let it go for the full time. So I'm going to do a manual start of my flow test. Okay. So when I hit start, it's running. Okay. So manual start is, it requires you to start the test and start the pump at the same time. Maybe I like that, maybe I want to be in control. But now if I don't have my pump ready to go, my timer's running and I've got no flow. So we can see right now it's telling us we have minus 100% error because I don't have any flow running and it's expecting it to be 100. So by the time I get my pump going, let's see, yeah, turn it on here. Okay, so we'll see if it's patient. Yes, we're on channel A. We have to set a rate. We want to do 100. And we want to do 10 milliliters. And, oh, it even calculates it out. Look, there you go, 6 minutes. Great. So let's start that. Thank you. Now it's running 100 milliliters per hour. It's telling me how much flow. You're going to do that from there.
Clog?
Air in mind.
Air in mind.
Oh.
I did mention this is a very finicky pump, right? Okay, so now our average flow rate is 13 milliliters per hour. And our instantaneous flow rate is up by 100. What gives? Well, I hit start, and it was manual start, so when I hit start, I told it to go, it went. And so it's accumulating time. We get our average flow rate, volume, over time. So you can introduce a huge error doing that, right? Whereas, if I pause this, let's stop, let's go back, change this from manual start to automatic start. Now, I've started my test, it's ready to go. As soon as my pressure, as soon as I start flow over here, pressure starts, now it's going to start measuring, and this time is now synchronized to when I hit start. So now we've got a better average flow.
And then you did all the priming ahead of time.
Yes, I already primed, it was ready to go, yes. Except for when it said there was an air bubble that I can't see.
Yeah, I was watching, I never saw one come through, but.
It's very sensitive, and as it should be, because, you know, if you start injecting air into your patient, that's bad.
Not good.
It's real bad. So, so that's the difference between the automatic start, manual start, and all of the settings, you know, all my tolerances, the air flow rates, when do I end the test, how do I start the test. And so in this case, because I told it to display grams, show the grams mode, like this service manual says you have to measure grams. Well, okay, we can't measure grams, but we can do the conversion. We're measuring volume to a pretty good accuracy, and we can convert that using the density that's in there and tell you how many grams that would be.
So why does that thing fluctuate so much on that instant? You know, it's been 75 and 117.
It's crazy, isn't it? So if you listen, there's fingers in here, right? So there's a motor that's doing something like this to push the water down.
Yeah.
And it has to reset and get back to the top. And then it does this, and then it has to reset. So when it does that, it's pausing. So there are very few infusion pumps that have a true continuous flow rate.
Like a roller type of.
Right. So the Harvard is actually, that's the one we use for calibration. And it's a syringe. It's got a lead screw, and it just pushes that syringe so it gets to the end, and that's it. And it's very continuous, it's very steady, it's a beautiful flow rate. You can't get any smoother than that. And so if we go to our graph, so we can show average flow, here's our instantaneous, that's what's happening. The flow rate is all over the place because these fingers, they're moving and then they pause, and then they move, and then they pause, you know. And every once in a while, it'll recalibrate is but it'll adjust itself and say, oh, I need to pause a little bit, and then now I'm gonna go again. And so you get a very it's a pulsatile flow rate. And that's what we see here in the instantaneous flow. Whereas now we can say average and instantaneous. The average flow is how much volume has been delivered over the time of duration of my test. And so that's a very stable number. Yeah. It started off, let's just do average. So it started off a little flaky, and then as soon as I got a little bit of data in me, now I'm pretty stable. And it'll just sit there. And this pump is pretty good. This is one of the better ones. Now some of them inside they have a piston, and it has to retract and then pushes, and And you'll get that. So in order for it to get the average flow, the instantaneous flow's gotta be pretty high.
Yeah.
Because it takes a period of time to pull it back and then push again. So, and this is one of the better designs. It's actually a really good pump, in that regard, as far as its continuous flow rate, or average flow rate.
Yeah.
So that's a great question. So here's our percentage. So we have different, we can show the volume, how much volume has been delivered, or our flow rate. And we get our bars up here. This is our tolerance. Our, whatever we programmed in for our plus minus 10%, is what we put in. And that's what it's showing there. Or we can hide the graph and see our actual data. So our average is a little bit low. And again, it really, this could be a 10% device, could be 20, kind of scary sometimes, but how wide the tolerance is on the.
You set the flow rate, expected flow rate on the 3400.
Mhm.
Then you set the same flow rate over on the Alaris.
Mhm.
And so when you say talking about the pressure, we get to a certain pressure before it starts. So how does,
And so this here is the current pressure.
Yeah.
So we set it to 0.2,
okay,
and so it's trying to maintain 0.2.
do you set anything over there? It's just measuring flow rate.
Complete.
So it's just taking the flow rate from there. You don't set any pressure. The flow
there's
rate's
no
based-
pressure.
The flow rate's the pressure's based on the flow rate.
The flow rate.
Okay.
Yep. So this is that, and that's a great question. So let me stop that one. This. Okay, so we saw our pressure was around 0.2, right? That was our setting. So I'm going to change this for, you know what? Let's just leave it at 100. Let's see what happens. Start. Restart. Start here. 600. Okay, so my pressure's pretty high now,
Yeah.
right? Because it's pushing pretty hard, right?
More volume.
It's got more flow. And so it's going to, so now I sped up, it's speeding up and it's speeding up, it's trying to keep that pressure down at 0.2. And, you'll see here, now we got 400% error because our average flow rate is 500, closer to 600 when I told it was gonna be 100. So if I got my settings right, it's more than, it'll do whatever you tell it, you know. It's a multimeter. It's the same thing as your multimeter. If you don't have it set up right, well, you're gonna get the wrong percent error.
Airball.
Yeah, and so we don't care if there's error,
Yeah.
in ours, because we're measuring pressure.
In this next video, we'll be demonstrating the occlusion testing and different modes of starting the test, such as automatic or manual start, and how that affects the testing data.
So the other type of testing we can do is obviously the PCA or the occlusion test. So the pump type is manual. We have a pump type setting in there. The idea is we could put in automatic mode where some pumps will auto reverse when they detect, and we haven't come across one, but supposedly it's out there, that when it detects an occlusion, it'll reverse the amount of volume that it put in so that it doesn't overdose, you know. But we only have manual. Start condition, automatic, same kind of thing with the flow test. The timer either starts when I hit start or it starts when it sees pressure. So I'll leave it as automatic, so it starts when it sees pressure. And then our test parameter is, we can either measure pressure, and this is for the pass-fail condition. So, pass-fail is either based on pressure or none, because we don't have any other options, it's doing occlusion. So, if you're going to measure based on pressure, then what is your tolerance? So we want to say, don't be over 10, and you gotta be at least 5 PSI. So that's all over configuration, we start the test. And now I go over here, let's say, hey, primary infusion, let's say 600 milliliters, let's just do 10 milliliters. There it is. Okay, and then we'll hit start. Now, 600 milliliters per hour. It's ready. Oh, it saw detect the pressure. It started the test. Boom, 4 seconds. Yep, got an alarm. So now I'm telling it when did the alarm occur, and I don't know if you saw it, but it said when it detected the alarm. Yes, I know. Stop. Okay. When it detected the alarm, it went into flow mode and it measured how much until it brought that pressure back to our back pressure of 0.2. And it measured how much volume was in the line that the pump, when I occluded, the pump started, how much volume did it deliver? It delivered a 0.5 milliliter. And so that's in the spec, that's either good or it's bad, or, you know. Now, if we're at 600 milliliters per hour and our pressure went up to 11.2. So it has to take some time and thinking and analyzing and, oh, now I'm looking at the pressure, right? So if let's rerun this test. And this time I'm going to set it to 100. We get all the good close. Push that button 100 times. Okay. No, stop. That's not one. I gotta get started with this. Okay, it already started. That's started. But anyway, I'm gonna run at 100 milliliters per hour. I guess it's still gonna do 10. Oh, there you go. 11.5. So.
It just took a little longer because the volume was.
I wanted to show that based on the flow rate, that pressure may change. Now it's got more time to monitor. Oh, it's gonna be right around 11. Okay, so
5 again?
So it's consistent, right? So maybe that's the spec for this unit. So I guess it's pretty good because it didn't care whether it was 600 or 100. 11 PSI, it was done, it stopped. So, and then there's a graph of this, so we can watch the pressure, peak pressure occurs here. If I was, thank you. So, if I was faster with my alarm, I'd be watching this, and as soon as it beeped, I would hit it, then it would show that was the end of the test there. But we can see it got to its peak pressure, and it never delivered anymore. The pressure just kind of dropped off. That's what we're looking for in the occlusion, so that it doesn't just hit it, and then, oh yeah, I'm gonna try and keep going and going and going. Blow up people's arms. That's the occlusion test.
Hey, let's go quick. Pump has the hydro balancing. Why do we don't need that?
It's not that we don't need that. So that may help the pump. So what that does is, if you consider this to be an IV bag, as I deliver water, the water level drops, right? What that does is, as I deliver water, it changes the height of the water. Okay, so that keeps a constant water column on your pump, the incoming side of the pump. Now, that poses the question, if I want to test this pump in a realistic environment.
That's not how an IV bag works.
That's not how an IV bag works. So how are you testing your pump? Do you want it to be in true clinical mode, how it's actually being used on a patient? Or do you want it to be in, well, let's keep a continuous pressure on the input so that it can function better? Now, there may be manufacturers that have a specification that say, yes, your level has to be at this point, water level has to be this high above the pump, and if that's the case,
For just testing?
For just testing, then, under these perfect conditions, now you have a 5% tolerance.
But when they test it, because we're drawing from the top versus an IV bag comes from the bottom, does that make a difference?
That will change the pressure in this line.
Right.
So,
But let's just get the fluid into the pump.
Fluid into the
pump. Doesn't the pump provide the pressure?
it provides the pressure coming out.
Yeah.
Right. And that's what our back pressure is.
Well, that's why I was wondering, what's the validity of the balancing that they're?
It is very effective in creating a constant head, I don't know what you call it, pressure, input pressure.
Yeah.
Very effective.
Now we'll be demonstrating PCA testing, which consists of a basal flow rate and bolus flow rates with multiple deliveries of injected volume. We'll demonstrate all the measurements and methods for performing this type of testing.
The important thing with doing a PCA test is the base flow rate is 20 milliliters per hour, and test duration, that's fine, we'll do an hour. Bolus test config, so this is our test parameter, we don't care. So you can do tolerance, pass fail, plus minus on each bolus. Lockout time that's going to tell it how long is the time in between. If you get a pulse, if you get a flow less than that time, it's going to say it failed. But we can set it to 0 because we don't care. So let's just start the test.
But since we're testing the pump, wouldn't on a PCA also be checking, if it says the limit is the patient can only hit that button 5 times in an hour?
Yeah, and that's what that bolus interval setting is. So you can set it for 6 minutes, 10 minutes, whatever. That's how fast it can get those boluses. And if it's any faster than that, then it fails the test. So we can say channel A is 20 milliliters per hour. That's what we told it. And volume is, let's just do 100. Get a number in there, 111. That's wonderful. Okay, so we can start that. And it's going slow. Okay, so it detected that. It's got the basal flow rate. It's doing its thing. Now I'm going to go in here. And I'm going to say, let's do 100. Oh, you're going to shoot. Do that. Now I'm going to go back in here. Change my rate back to 20. Okay, so it delivered, it detected it. It saw the flow rate change. It said, oh, that was a bolus. Your flow rate for the bolus was 90, and it delivered 0.3 milliliters. The duration was 12 seconds. So as we get another one, and then also the view all screen changes based on now we're doing a bolus test, so my view all changes to show me more information. And also if I go to any other screen, it's telling me you're doing a PCA test. Just so I can get a preview, I know if I was running 4 channels, this one's PCA, this one's Occlusion, whatever. Right? So now let's do another bolus of 100. Here we go. Now it's seeing its new flow rate. It sees that. It's going to detect that as a new bolus. So we can change that back down to 20. And there it is. Ooh, oh, it's pretty close. 12 seconds. So interval is 47 seconds. So it just keeps on going. It'll measure all those pulses. You see the graph? There's one, and there's the other. So the PCA test is showing you instantaneous flow rate because when you're going from 20 to 100, that average is going to take a long time to get up to what doesn't really make sense. So it's just showing you instantaneous flow rate, and that's just all the little blips and loops that it's got. So anyway, we can keep, this was the first bolus, the second bolus, so it'll keep moving these down.
Oh, that's interesting. It
shows
the first one, the last one's first.
The last one, yeah. It's kind of smart like that, because otherwise, if you go the other way, once you get to 10, it's like, oh, it's way over there.
Yeah.
So
if you hit a PCA pump, are we testing the lockout too?
you would be testing lockout. So you would want to hit that
6 times instead of 5.
Right.
You lock out after 5, it's over
Right.
6 when it locks you out.
Yep.
Yeah, that was, thank you, that was the other part of my.
Yeah. Now, we do have hardware, we have hardware in the 3400 to be able to do that. And so that's our PCA test. So, those are the 3 test modes. That's all, really all there is to it. We can save our results. So this saves it to a DAT file, which is basically a comment unlimited file. And you can view these files can be viewed in BC Flow, and then that can create PDFs if you want a PDF report.
In this video, we'll be demonstrating how to remove or drain a flow module for storage or return for calibration. In this case, we've completed our testing, so we have fluid all throughout our inlet and outlet tubing, and we want to make sure that we properly drain the system for storage or calibration. So I'm going to go into my channel 1 screen here, and I disconnect the inlet tubing. Now this has a automatic cutoff inside the pump, so I don't have to worry about fluid draining out there, but I do have my outlet tubing still connected. I'm going to go ahead and press the drain button, and what this does is it activates the internal pump, and it's forcing the inlet all the way through the system. So right now I have nothing connected to the inlet, so it's going to pull in air and force the air through the internal flow module. And we can see here that we're starting to see the air bubbles come out, and we want to make sure we get as much of that out as we can. Okay, so at this point, it is drained. I can hit done here, and I'll go ahead and disconnect the outlet and make sure I don't get any gravity back feeding the fluid onto my table. Now we need to remove the flow module. Everything's disconnected, it's drained, it's ready to go. So anytime that we remove or install flow modules, we need to turn off the power to the IPA 3400. When we flip up the lid, we'll see some instructions here on how to perform this removal. But essentially there's 2 thumb screws on the front that we will remove, or loosen, not really remove, and then we can remove the front panel. And underneath, there's also a thumb screw for each module. And there's a tab here. Once I remove the front panel, I can have access to this pull tab. I just pull the module right out, and now it's ready for return. Now the packaging that the unit comes in is great to keep for this purpose. For my annual calibration, it's got foam built inside that is perfect for holding the flow module, and it keeps it safe during shipment to and from BC Group while we do your calibration. And now it's ready to go, and we can return this unit for calibration. The important thing to realize is that we only have to calibrate or send in 1 channel at a time as it's due for calibration. I don't have to send them all in, so we can start with 1 module and then expand to another one in another 6 months or so forth. And so that way we don't have to recalibrate all of them at the same time. I can stagger calibrations and continue calibrating throughout the year as I need to. So that concludes the removal of the IPA 3400 module, and thank you for watching, and thank you for your interest in BC Group products.
BC Group thanks you for participating today in Webinar Wednesday, courtesy of MD Publishing. If you want more demonstrations of our BC Group products, subscribe to our YouTube page. Now, Megan Strand of MD Publishing will be moderating our Q&A session. Again, thank you for participating today in Webinar Wednesday.
Thank you so much, Lucio, for that presentation today. I'm really excited, though, to get started with our live Q&A. I am going to have Dennis Groom on the line. He is the lead engineer for the BC Biomedical 4-channel IPA 3400. Dennis, how are you doing today?
Hey, good afternoon. How are you doing?
Doing well. Thank you for joining me today. I know we had a few questions come through from the audience, so I'd love to start with those first if you're all right with that.
Sure.
Great. So the first question that I received was, The MFG's recommendations are similar to real patient scenarios, so why wouldn't you want to simulate as close as real situations as possible?
That is an excellent question. We actually do try to simulate as close as possible. For instance, we have a user-selectable back pressure setting, which simulates the pressure in a patient's veins that would push back against an infusion pump. So that's what it has to overcome. And the way we simulate the back pressure is that we don't actually begin measuring until pressure exceeds that setting. So we try to make it as realistic as possible.
Great. Another question that came in from the audience is, why did you say air in line would not be affected on occlusion pressures?
Well, we use a stainless steel pressure sensor that doesn't throw errors or respond poorly to bubbles and lines or pressures. Or air in the line. We've tested extensively, and we haven't found that having air in the line during an occlusion test really causes any kind of error on the pressure measurements.
Okay, and I have one last question. Is it possible that you, BC Biomedical, can train people interested in medical instrumentation in your products? In my country, this is from the audience here, we lack such expertise, and most health centers convert those in instrumentation to start working on medical instruments.
That would definitely be a good question for our sales manager, Tim, who I believe is on the line. He could answer that one for you.
Hey, Megan, could you? Yeah, I'm here. Hey, could you repeat that question? I was kind of wasn't sure what the question was aiming towards.
Sure. Sorry, this one came in last minute, so I didn't have a chance to send it over. Is it possible that you, BC Biomedical, can train people interested in medical instrumentation in your products? In my country, we lack such expertise, and most health centers convert those in instrumentation to start working on medical instruments.
Okay. Yeah, and BC Group, we're very user-friendly. And, the goal is, just selling a piece of equipment is not the end of it. If somebody needs some technical or help and support, either starting up or, gaining a little bit additional knowledge on how to operate it, we can do a one-on-one training through, teams, etc. Yeah, so we're there to help. We're not here to hang them out and let them drive for just because they bought a piece of equipment.
Perfect. Now we have a couple more questions coming through. Dennis, can I run 4 separate pumps with varying testing needs?
Yes, each pump has an independent set of data and settings inside the unit. You could have one channel running flow test, another one doing occlusion. You could have them all running different tests, different settings. They're all completely independent.
Okay. Another question I have is, what effect do bubbles have on the physical test?
They actually have very little effect because of the way we are measuring. We're not using bubble following or tracing or LEDs to track the meniscus of the water. We're actually measuring the flow of the volume through the system using syringes, so it's not susceptible to the same errors introduced by bubbles.
Thank you. And one last question for today. What are the options for exporting data?
Well, we can save test results to a PDF format or to a proprietary data type, data file that you can load on USB and bring over to a PC to be processed with our PC companion software called BC Flow.
Perfect. Well, let me just make sure I didn't miss anybody's questions. I think we got through them all. So Dennis, I appreciate you being here with me today to go through any last minute questions our viewers had today. But I appreciate your time. So I'm just going to go into a few closing remarks. Thank you again to both of you for your time today, and it was a great presentation. I'd like to encourage everyone to visit today's sponsor to learn more about the products they provide to our industry. Visit bcgroupstore.com. A quick reminder, you can obtain your CE certificate by completing the post-webinar survey. The survey will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit from the ACI, and you will be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. We will be back next week with another webinar. Visit webinarwednesday.live for more details and complimentary registration. Thank you and have a great day.